Hello students, in this session I'll be continuing with module 4 dynamic programming. Here we'll be dealing with the knapsack problem and the knapsack problem solution using dynamic programming. In the previous video I have already explained you what is knapsack problem, how the knapsack problem can be solved using greedy method. We also have implemented this knapsack problem using Java. So here we are going to deal with the same knapsack problem, but this is the 0-1 knapsack problem and the solution is using dynamic programming. As you all know, knapsack problem, in the knapsack problem, you will be having set of items. Each item has got its own weight and the value. You also have got knapsack bag with the maximum weight. Our intention is to find the subset of the items to fill the bag so that we get the maximum profit, and also the total weight of the items doesn't exceed the capacity of the bag. So this is the definition of the problem. Given n items of the known weights, so we use the alphabet W for representing the weights of the item, W1, W2, so on up to Wn, and the values V1, V2, so on up to Vn. These are the values of the items or the profit what we gain if we select the items, and also the knapsack capacity. We use the letter capital W. Our problem is to find the most valuable subset of the items that fit into the knapsack bag. So here we are going to see the dynamic programming solution for the knapsack algorithm. As I have explained you about the dynamic programming strategy in the beginning of this module, in the case of dynamic programming strategy, we deal with the sub-solutions. That means in order to find the final solution, we will be building the sub-solutions, and from these sub-solutions we'll be coming up with the final solutions. So some of the terminologies or the alphabets that is used to represent the knapsack problem is, here we are going to use the variable n to represent the number of items. W, as I told, it is for representing the weights. V1 to Vi to represent the weights. So two more variables we are using, one is I and one more is J. I is actually used to represent the index of the items, and J is actually to represent the different weights. So here we are dealing with the sub-solutions, sub-instances of the problem. So if the maximum capacity is 5, we don't directly go to find what is the solution when the knapsack capacity is 5. We will first see what is the solution when the capacity is 4, when the capacity is 3, when the capacity is 2. So in order to represent these different knapsack capacities, we use the variable J, and capital V of I comma J, this is actually to represent the solution to the sub instance or to the sub problem, and even the final solution also we are going to represent using V of I comma J. So in order to solve this knapsack problem, so we will be building the sub-solutions. These sub-solutions are maintained in a table. Let's see how to form the table for the knapsack problem. How to create the table for the knapsack problem. So in the table we are representing the sub-solutions. In order to store the sub-solutions, in order to come up with the final solution, we are going to store all the result of the sub-solutions in the table. So now, what should be the total number of rows and what should be the total number of columns in the table? Both the row index and the column index must start from 0. So this is 0, the row number, and the column number 0. Both should start from 0. Next, the total number of rows. What should be the total number of rows? So starting from 0, the index of the next row should be 1. Index of the third row should be 2. So on up to n. N is nothing but the total number of items. Now in this example, if I am considering, we have got 4 items. So the row index starts from 0 and then it is 1, then 2 and then 3 and then 4. So n is nothing but 4. So there should be total 5 rows. Now about the columns. What should be the total number of columns? So we know that the first column index should be 0 and then it is 1, 2, gradually it is increasing by 1 and the last column should be the maximum capacity of the bag. So you know that W, capital W is used to represent the maximum capacity of the bag. So the last column must be W. In this example, W is equal to 5. Capacity of the bag is 5. So, there should be total 6 columns. 0, 1, 2, 3, 4, 5. Total 6 columns. Now, that is about the total number of rows and total number of columns in the table. So, next thing is, how to fill the table? How do we fill these values? Now, in order to fill these values, we make use of the recurrence relation. So, this is the recurrence relation what we are going to use in order to fill the values. Remember, all of these entries, all of these values. Now, this is actually the 0th row, 0th column value. Now, we represent that as B of 0, 0. So, I is nothing but the index of the row. I is nothing but the index of the row. J is nothing but the index of the column. So, what is I here? I is actually, it represents the total number of items. So, if you take the first row, so in this case we are going to consider 0 items. So what is the solution when there are no items? So there are no items at all, but what is the solution? That is actually required in order to build the next set of sub-solutions. And when you take I is equal to 1, that means there is one item. So we are considering the first item, there is one item. And if you go to 2, so 2 means we are considering 2 items. 2 items means we are considering first and second item. So that means we have 2 items and we have got a knapsack capacity. That is, we have got a knapsack bag. We have to find the solution. Now again, the column indices 0, 1, 2, 3. So all these are actually the different knapsack capacities. The actual capacity of the bag is 5, but we don't directly start from 5. So we are going to build the solution by building the series of sub-solution. So sub-solution is, we consider when the knapsack capacity is 0. We find the solution when the knapsack capacity is 1. We find the solution when the capacity is 2. So on up to 5. So if I say this entry V of 0, 0 is what is the profit gain when there are 0 items and the capacity of the bag is 0. Now if I take this entry, now let us take this entry, this one, that is I is 2 and J is also 2. Now we are finding what is the value or what is the profit gain when there are 2 items and the capacity of the bag is 2. So if you take here, what is the solution when you consider n items and the capacity of the bag is 0? That is the meaning of each entry inside the table. We use the capital V for representing each entry inside the table. So this first entry is V of 0, 0. Second entry is V of 0, 1. V of 0, 2 and so on. That is how we enter the values. Now, how to fill these values? So, we have got a recurrence relation. What is the recurrence relation says? V of I comma j is equal to max of V of I minus 1 comma j. Now, what is I minus 1 comma j? I is nothing but it represents the row. If I say V of I minus 1 comma j means the previous row value of the previous row, column is same, column is j itself. Now for example, if I take v of 2 comma 1, then what is v of I minus 1? It will be v of 1 comma 1. That means what is the value in the previous row and in the same column. So that is the meaning of v of I comma j, comma max of this value, comma vi. Vi is nothing but the value of each item. Now if you are considering this first item, what is the value of that item? That is how we represent the how do we represent the value of the each item. Vi plus capital V of I minus 1. I minus 1 is again the previous row. J minus Wi. Wi is nothing but the weight of the item. So J minus I. J is nothing but the weight of this weight what we are representing in each column. So J minus Yi is nothing but when you don't consider this weight, what was the previous weight? So that is the J minus Wi. J is the previous weight. J is, now for example you consider J is 2 and Wi, weight of the first item, what we are considering is 1. J minus Wi is nothing but 2 minus 1, that is equal to 1. So V of I comma j is equal to max of V of I comma 1 comma j or comma Vi plus V of I minus 1 comma j minus Wi. If j minus Wi is greater than or equal to 0. Now what does this indicate? J minus Wi is greater than or equal to 0. So this says whether we can include the item inside the bag or not. Now let us take J is nothing but the capacity of the bag. Capacity of the bag is 3. Let us take J is equal to 3. Now weight of the item Wi is equal to 4. Wi is equal to 4. Now if I do 3 minus 4, that is equal to minus 1. It is less than 0. Right? Now if I take Wi is equal to 3. So then 3 minus 3 is equal to 0. So here when J minus Wi is greater than 0, only if we can consider this item to put into the bag. Now if J is 3, then if the weight of the item is 3, then we can consider this item. You can put that item into the bag because weight is less than or equal to J. Suppose if weight is greater than or equal to J, then you cannot put that item into the knapsack. So that is nothing but the second case. Suppose if J minus Wi is less than 0. Suppose if you are not able to consider the particular item, then what will be the profit gain? Profit gain will be the previous value only. Previous value is what? V of I minus 1 comma j. So that is the meaning of this. Here if J minus Wi is greater than or equal to 0 means you can include the item. If you say J minus Wi is less than 0, you cannot include the item because J is the capacity of the bag is less than the weight. So for this recurrence relation, we also have got the initial condition. So this initial condition is required because here you say V of I minus 1 comma j. Now for finding the first value, now suppose if this initial condition is not there, so then how will you find? Here you don't know what is the previous, there is no previous value at all. So that is why we have got the initial condition. So what is the initial condition says? If capital V of 0 comma j is equal to 0. So whatever be the value of the column, suppose if the row is 0, then the value is always 0. Then one more case is, suppose if the value of j is 0, but the value of I can be anything. In that case also it is 0. If I is 0, then the value is 0. If j is 0, then also the value of 0. So if you take this first row, I is 0. So j values are different. It is from 0 to w, but I is 0. That is why all these entries are 0. V of 0, 0 is 0. V of 0, 1 is 0. V of 0, 2 is 0 till the last value. Similarly, V of I, 0. Suppose if the value of j is 0, then also the values are 0. So in this column, all the values are 0. Why? Because the column j is 0. Next we'll look at the example. We'll go to the actual example and then we'll build the table using this recurrence relation and we'll see how to get the final solution. One more thing is, where will be the final solution? Actually we are interested in only one value. What is the profit gained by considering these items? When you consider these items and the knapsack capacity 5, what is the profit gained? What is the optimal profit gain, or what is the largest profit gain? That we want. So that we get in the last row and the last column. So last row, last column, what value you get, that is the solution to the problem. And also we have to find the subset of the item. What are the items that you have to consider in order to get the particular profit? But remember, the value what you get here at the last position, that is nth row and w column, that is the solution. Or I can also write this as V of n comma capital W. This represents the final solution, or that is nothing but the total profit considered, total profit gained when there are n items and the maximum capacity is W. Now we'll find the solution for this problem. So here we have written the item. There are 4 items here. Weights of the items are given. Weight of the first item is 2. Weight of the second item is 1. Then third item is 3. Fourth item is 2. Similarly, the values of these items are given 12, 10, 20 and 5. What we have to do? We have to draw the table wherein we are going to maintain all the sub-solutions. So, as I told, the row index must start from 0 and the next index should be 1, 2, so on up to the last index is n. N is nothing but the total number of items, that is 4. Next, the columns. Columns also, it should start from 0. Then the next column is 1, 2, 3, so on up to the weight, the capacity of the knapsack bag, that is 5. Capacity, W is 5. So the last column is 5. Now we have got the initial condition. We know that V of 0, j, whatever be the value of the column, if the row is 0, then all the entries must be 0. If the column is 0, whatever be the value of row, then the value should be 0. So what it indicates? When there are 0 items. See, suppose if there are no items at all, and also there is no, in this case, there is no bag at all. Capacity of the bag is 0. So that means the bag is having no capacity. So obviously the value should be 0. Or if you consider this case, so here there are no items, then what profit you will gain? So all these are when there are no items. There are no items at all, then what you will fill? So obviously the value or the profit what is gained is 0. Next, in this case, there are items. You have got item here. You have got 2 items, 3 items, 4 items. But the capacity of the bag is full. It is 0. That is why you cannot fill any of these items into the bag. Even in that case, all the value v of 0, I, 0 becomes 0. Next, we will find the remaining values. We have to find all the entries until we find this last one, v of 4, 5. That is our final solution. Now, how to find this one? So, we have to use the recurrence relation. Now, we are going to find v of 1, 1. We are finding v of 1, 1. So, what is the recurrence relation says? We have got 2 cases here. One is j minus wi is greater than 0. What is j? J is this. These are the j values. Now we are going to find this j. J is 1. So j is 1. So 1 minus wi. Wi means weight of the ith item. Weight of the first item. What is weight of this item? Is 2. So 1 minus 2 is greater than 0. No, it is not greater than 0. 1 minus 2 is minus 1. So you have to consider the second case. What is the second case says? If j minus wi is less than 0, then v of ij should be v of I minus 1j. I minus 1 means the previous row. So what is the previous row? Same column. Previous row, same column means this one. Correct? Previous row, same column. V of 0, 1. So, you have to fill the same value for this one. So this will become 0. So, next we are going to V of 1, 2. Now, we are considering 1, 2. Now, look at this. We have got one item here. Whose weight is 2, value is 12. And the capacity of the bag is 2 now. Capacity of the bag is 2. Now again you consider whether j minus wi is greater than or equal to 0. Weight is 2. J is also 2. So 2 minus 2. J minus wi is nothing but 2 minus 2. It is equal to 0. So that means it is the first case. So what is the first case says? Max of v of I, 1j. v of I, j is nothing but the previous value only. So max of 0. 1 is 0. This is the previous case. Comma. Vi. Vi is nothing but the value of this item. What is the value of the item? Value of the item is 12. Plus v of I minus 1. v of I minus 1. V of I minus 1 is V of I minus 1. What is I? I is 1. 1 minus 1 is nothing but 0. Comma j minus wi. J minus wi. J is nothing but 2. Wi is nothing but 2. So 2 minus 2 is nothing but 0. So V of 0, 0. So 0, 12 plus V of 0, 0. So what is V of 0, 0? So we know that it is 0. So it becomes max of 0, 12. So that is nothing but 12. Next is V of 1, 3. So you have to consider V of 1, 3. So 1, 3. Now again, so we know that the capacity of the bag is 3 and the weight of the item is 2. So 3 is greater than 2. So we can consider the first case, max of V of I, 1, j. So that is nothing but again max of 0 comma vi. Vi is nothing but 12. 12 plus v of I minus 1. I minus 1. I is nothing but 1. 1 minus 1 is 0. Comma j minus wi. J is nothing but 3. Minus wi. Wi is what? 2. That is what? 1. V of 0 comma 1. So which is v of 0 comma 1? V of 0 comma is also 0. So that is max of 0 comma 12. So that is nothing but 12. So like this we continue for all the values. So we get 12 and 12. So you do it for all the rows. So here what we are doing is, this is a one item what you have. One item. Its weight is 2. Value is 12. You are considering the bag with the capacity 0, bag with the capacity 1, bag with the capacity 2, 3, 4 and 5. Why this value is not changing? Why 12 is remained as it is? Because we have got only one item and the profit of that item is 12. So even if you have the capacity, so here the capacity is 3. There is one more space. Actually one more capacity is remaining. But there are no more values. We have only 12. We have only one item whose value is 12. So that becomes 12 itself. All the values are 12. Now we'll start finding the values of the third row. When you are finding the values of the third row, remember we are considering two items because index of the row is 2. So we are considering two items. It is not just the second item, we are considering two items. Before that you also should remember that the items are written as it is from the first item, second item, third item and the fourth item. We have not ordered. How it is given in the question, in the same way you have to write in the table. So when you are coming to the third row, that is row is equal to 2, you are considering two items and the weights are, one is 2 and 1, the values are 12 and 10. Now you have to find what is the profit gained when you consider only these two items, and the capacity of the bag you are considering it as 1 once, again you are considering as 2, 3, 4 and 5. You have to consider all the 4 cases. Now first case is W2 is equal to 1 and J is equal to 1. So here we are actually considering we are finding V of 2 comma 1. So I is 2 and J is 1. We are considering 2 comma 1. So when you consider 2 comma 1, how do you find 2 comma 1? So you have to see the recurrence relation. Before that you have to see which condition holds good. Whether J minus W is less than 0 or greater than or equal to 0. So J is what? J is 1. What is Wi? Wi is 1. So 1 minus 1 is actually equal to 0. So that means it comes to the first case. In the first case what it says, V of I comma j is equal to max of V of I comma 1 comma j. That means the previous row value. Previous row value you can directly write 0. Comma Vi. Vi is what? 10. 10 plus V of previous row. Previous row is what? 1. So it is 1. And the J minus Wi. What is J? J is 1. Wi is also 1. So it is 1 comma 0. So in order to, while we are actually calculating this value, right? We are calculating this value. In that case, you are considering this. So V of 1 comma 0 is nothing but this value. We are considering this. So max of 0 comma 10 plus V of 1 comma 0. So that becomes 10. So it becomes 10. So the second entry is 10 here. Next entry, V of 2 comma 2. How do you calculate V of 2 comma 2? Now to calculate V of 2 comma 2, First see the capacity. Capacity is 2 here. J is 2. So obviously it comes to this case, right? So 2 minus weight is 1. So it is greater than 0. So it comes to the first case. So now max of B of I comma 1 comma j, that means the previous value, max of this, that is nothing but 12, comma Vi. Vi is what? This one. Vi is 10 plus B of I comma 1 j comma j minus I minus 1 comma j minus wi. I minus 1 means the previous row. J minus wi. J is what? 2. Wi is what? 1. So it is 1. So we are finding this value. See, we are considering this. So it is 10 plus 0. 12 comma 10 plus 0. So for this one we have considered this. Like this we have come. So now this one is, so that will be 12 itself. See why it has changed here from 10 to 12. Here you had the knapsack capacity 1. So though there are 2 items, we can put only this item because its weight is 1. You cannot put this item. You can put the second item and the profit what you gain is 10. But when you come to this one, the capacity of the bag is 2 and you have got 2 items. You have got the second item, you have got the first item. Out of these 2, which one you will consider? Obviously you will consider the first item because it is having the profit 12. If you consider the second item, then it is having the profit 10. So we are interested in the maximum profit. So that is how we got 12 here. Now next we'll go to the third value. So third value we are finding V of 2, 3. We are interested in finding 2, 3. Even here J value is greater than the weight. 3 is greater than the weight. So of course it will come to the first case. So when it comes to the first case, now what? Max of previous value. Previous value is what? 12. Comma, value of the item. What is the value of the item? 10 plus. So 10 I have written as it is. And then what you have to consider? This one, right? So for this you have considered this. For this you have considered this. So you can apply the formula. V of I comma I minus 1 comma j minus wi. It will come to this. So that is nothing but 12. So it is 10 plus 12. So max of 12 comma 10 plus 12. So which will come to 22. 22. Now see why we got to 22. Here the capacity of the bag is 3. So we can fill both the items because weight of the first item is 2, weight of the second item is 1. When you add it together it becomes 3. That is why when we can add the profit of both 12 plus 10. So that is how we got 22. Next capacity of the bag is 4. See, we can directly write the value actually because capacity of the bag is 4. But we have already considered both the items and we got the value as 22. So though there are capacities, though there are still more space to fill inside the bag, we don't have any more items here. At the max you can get 22 itself. So I can directly write 22 here. So 22 for all the remaining values. You can directly write this values. Similarly, you calculate for the third row, fourth row. So when you consider this fourth row, you have to consider 3 items. Now there are 3 items here. 3 items and then capacity of the bag. Here the capacity of the bag is 1. There are 3 items. Capacity of the bag is only 1. So of course I can directly write it as the value as 10 itself because you have got the first item as well as third item, right? But its weights are more than this one. So more than the capacity of the bag. So anyways, you can consider only this. So it will come to 10 itself. Similarly, you calculate the remaining values. With the same procedure to get the remaining values. So I have calculated for the fourth row. In fourth row, we consider 3 items. Then you repeat the same procedure. Apply the same recurrence relation for the fifth row also. So in fifth row, we consider all the 4 items. So finally, at the end, so the value what we get. So this is actually the optimal solution. I can write this is the optimal solution. So this value represent the total profit gain when there are 4 items and the capacity of the bag was 5. That is the question given. There are 4 items and the capacity of the bag is 5. What is the profit gain that you are supposed to calculate? All these are the sub-solutions. From these sub-solutions, we have built the solution. That is why this is dynamic programming strategy. So now I can write the answer. So total profit gain from these items and the capacity is 5 is 37. 37. So next is, this is not the end of the problem. So if you just find the total profit gain, that is not enough. So you also have to find which are the items that are selected to get this total profit. Whether only the first and the second items were selected or first and second or all items are selected. What is the subset of the items those are selected for getting this profit? So that have to be calculated. So how to calculate this? So to calculate this, we use the backtracing method. So in the backtracing method, we start from this last value. Last value is what? 37. So this is V of 4, 5. You have to compare V of 4, 5 with the V of 3, 5. So that means you have to compare this with the previous row value. And you have to check, are they same? If they are same, that means this particular item is not selected. See, the formula you know. J minus Wi is greater than or equal to 0 means what? We can select the item. J minus Wi is less than 0 means what? We cannot select the item. If we have not selected the item, then the value will be the previous value itself. If we have selected the item, then only the value will change. So here the value was 37. In the previous row it was 32. Now it is changed to 37. Why it has changed to 37? Because we have selected this item. That means in our subset, so we have this item 4. So what you have to do is you have to backtrace the table. You have to start from the last value. You have to compare that with the immediate previous value. In the previous row, same column, what is the value? If there is a change, that means this item is selected. The last item is selected. If there is no change, now suppose if here also it was 37, that means we have not selected this item. We were not able to select the item because it was exceeding the capacity. But here the values are different, so that means the item 4 is selected. So I can write in the subset of the solutions, I can write one item that is there in the solution is item 4. Next, what you have to do? So next, don't compare this and this. Now, see, when you have already selected one item, what is the weight of that item? Is 2. What was the total weight of the capacity of the bag? Total capacity of the bag is 5. So, one item is already selected. Its weight is 2. Now you have to update the weight. How do you update the weight? 5 minus 2. 5 minus 2 is what? 3. So, now the knapsack capacity is 3. Now we are seeing the remaining 3 items. Fourth item we have selected. The remaining 3 items and the capacity of the bag is 3. That means we have to look at V of 3, 3. We have to look at V of 3, 3. Please don't compare this and this, immediate this one. You have to go to V of 3, 3. You have to update the value of the weight and then the previous row. Row will be same. So you have to consider this value. Now you have to consider this. Now this you have to compare with the immediate previous row. So this and this you have to compare. Now check 22, 22. It has not changed. Why it has not changed? Because J minus Wi was less than 0. We were not able to include this item. If we were able to include this item, then definitely this value would have been changed. But the value has not changed. It is 22 itself. The previous row also 22. Here also it is 22. Actually, this is the second case. So, that means this particular item is not selected. So, don't consider this. In the subset of the item, I don't write this. So, next what we have to do? Now, again you have to update the weight. But anyways, we have not included this item at all. So, there is no question of updating the weight. So, the weight J value will remain 3. But now we are considering only 2 items. With the 3 items it is over. 4 items also it is over. Now it is V of 2, 3. So that means you have to look at this one. You have to look at V of 2, 3. You have to compare that with the previous value. So what is the previous value? Previous value is 12. So now there is a change, right? So here it was 12, here it is 22. So that means this was the first case. Only because we were able to include this item, so the value changed from 12 to 22. That is why we can say that item 2 is also there in the subset. So I'll write it as item 2. Next is you have to update the value of J now. So since you have included this, what is its weight? Its weight is 1. So previous weight was 3. So 3 minus 1 is what? 2. And now we are left with only one item. So you have to look at V of 1, 2. So where is V of 1, 2? Here. We have V of 1, 2 here. Now you have to compare that with the previous value. Its previous value is what? 0. Again there is a change, right? There is a change from 0 to 12. It is not same as the previous value. That means we have selected the first item. So item 1 also comes in the subset. So here I can write inside the subset we have got item 1. So now what is the optimal selection here? When there are 4 items and the capacity of the bag is 5, if we select item 4, item 2 and item 1, then we can gain the maximum profit. So here only item 3 doesn't come into the picture. And see, you can calculate the weight 2 plus 1 plus 2, that is equal to 5. And also the total profit gained is 12 plus 20 plus 5, 32 plus 5, which is equal to 37, which we have already got. So back tracing method is simple. You have to start from the last value. You have to compare that with the previous value. If there is a change, that means the item is selected. If the item is selected, you have to update the value of J, and with respect to that J and the previous column, you have to consider. And then you have to compare that with the previous value. Here there is no change, so that means 3 is not selected. Next you have to compare this 12 with the 22 with the 12. There is a change. Item 2 is selected. Since item 2 is selected, you have to update the weight now. So 3 minus, weight was 3. 3 minus 1, now it is 2. So when the weight is 2. So you have to consider when there is only one item. So this is the case. So 12. This you have to compare with the previous value. It was 0. It is not same. That means item 1 is also selected. So that is how we can solve the knapsack problem using the dynamic programming method.